Read the question. Now the graph, something graphical information is given, potential versus X graph. Okay, how to proceed here? So let's directly go for at position X1, we'll go for it. At X1, overall mechanical energy. One, let me use word one symbol, U1 plus K1. U1 is how much? -2 from the graph. Kinetic energy is how much? 1. Kinetic energy should be positive. So the total mechanical energy of the system is how much? -1 joule. So the body cannot have energy more than -1 joule. The overall mechanical energy should be constant here. Now, okay, you take this one. If I slightly displace it, there's a 1. If I slightly displace it, how the force will act? There's a graphical analysis. Student has to bring its graphical analysis into the picture. There's a rough graph. -1. Okay, this was the reference point for us, the stable equilibrium. So there's a 1. Now come for this. If I slightly displace the object, let's assume that the particle is here. There's no particle. Let's assume a point there. Now, how the force, if you calculate the slope in, because what is F? F equal to du by dx. We'll calculate the slope. At point A, we'll take this one. This is a point A. At point A, what is the slope? Slope is positive. Slope is positive. If slope is positive means du by dx is what? Positive. Then what about f? Fx equal to minus du by dx. And substitute du by dx with sign all together, I'll get fx negative. So what direction the force will act? The force will act on the object. You need reference diagrams, I'm telling this one. Without this, not possible. Here, there's a position 1. I brought position A. When I displace the object like this, I'm seeing that a force will act in this direction. This you call Fa. Sir, how come you say Fa negative? I got Fa negative, you see. Du by dx is positive at point A. If I slightly displace this object is not displaced here. There's a curve. Object will move along x-axis only here. Please understand here. Object will undergo displacement along x-axis. There's a position 1 I brought it. If I slightly displace to point A, then at point A, the force will act towards left. How do I'm telling you this one? Similarly, you displace to a point, select a B. This analysis of graph. At point B, what the slope? Slope is negative. Du by dx negative, and we know fb equal to minus of, I got fb positive. Positive means if you displacement object to the point B, how the displacement given like this, how the force will act in this direction. So look at one, shall we call one as stable equilibrium? Yes, in fact, and also moreover, if you calculate slope here, what is the slope at this particular point P? Let me call this as a point 1. This is at x equal to 1, no? At x equal to x1 or at point P, what is the slope? Slope is in fact 0. Should be 0. So therefore, now and potential is in fact minimum. You see, so many things are there. So what do you say about the point x1? Stable equilibrium or unstable equilibrium? It is a stable equilibrium. So therefore, x1 is a it will oscillate. We know already, I shown you. If you slightly displace, the force will act towards left. If you displace towards left, the force will act towards right. So therefore, it oscillates. Then, what about it moves to the right of x3 and never returns. It comes to rest either at x0 or x2. Something cannot reach either x0 or x2. How to judge about BCD? What is the total mechanical energy? -1 joule. Then if I slightly displace, can I displace it till x0? Because what is the potential energy at x0? Will be 0. What is the total mechanical energy? Will be -1 joule. So when it is oscillating at extreme point, what should be the kinetic energy? Kinetic energy should be 0 at extreme point. And potential energy is 0. The total mechanical energy will become 0. But how much maximum it can possess? -1 joule. So what is the maximum permitted distance it can undergo displacement here? Maximum this one only. So there's a maximum permitted. The permitted is what? I'll put it here. This you call say some P already we took it, no? C and D. The object what happened cannot have the displacement, cannot overcross the D or C. The reason, what is the maximum mechanical energy it will have? -1 joule. And at extreme point, if it is oscillating, at extreme point, kinetic energy should be 0. Then what is the potential energy now? -1 joule. So therefore, no question of reaching x0 and x2, no? So all these are ruled out. This option B and C. It cannot reach either x0 or x2. X correct. Because maximum what happened? It can reach C and D. Because at C, what is the total energy will be -1 joule, as it is justified. And if it is oscillating between points C and D only, it will be confined here. And you look at the D, it is somewhere at a distance less than x2 and x0. Okay, are you getting something? You have to analyze the graph here. You don't have any equations, sir. Can you give some equation? No, the analysis has to be done. What all we studied, graph, slope, this is the purpose of this one, not differentiating. So many differentiation problems you are practicing blindly. What was the use of this? No use. That's why I always insist you have to understand and analysis is very important. So now what we can say, the particle oscillates between okay, I think within this will be confined, no? So what about C and D? C and D, I'll bring it somewhere here. This is C, this is D. make observation. We have to start the next topic. Now, there's one question you have to that we only that it has become you. Okay, don't get confused. I'll make it you. Yeah.